Okay, welcome to lesson 2 of week 4. And I am super, super excited. We get to start doing derivative rules. You guys, these are like shortcuts. They're faster ways of finding derivatives, which means no more do you have to do all of this, right? No more do you have to use this formula, because I am going to teach you some shortcuts. And we're going to start with the one that is actually the most common. We use this a lot, and that is the power rule. And the power rule works for polynomials. It does not work for a polynomial times a polynomial or a polynomial divided by a polynomial. It just has to be a regular polynomial as long as you want it to be, okay? And the power rule is pretty awesome to find the derivative. And remember that that's the notation for derivative, right? Using the power rule, you simply take that exponent, multiply it by the coefficient, and then remember what I just taught at the end of the last video. Every time you take a derivative, the exponent decreases by 1. So if this is a 9th power, then the derivative is going to become an 8th power. So we're going to multiply it and then decrease this by 1. So if I take that 9 and multiply it down there, that negative would still be there. So that would be negative 45 halves, and then x to the 8th. Don't forget that part. You have to decrease that by 1. So the power rule says bring that exponent down to the coefficient and then decrease this by 1. Pretty simple. Okay, but of course they've got to throw in something that might trick you, but I'm hoping that if you listen to me that it won't trick you, and they're going to give you something like this. And remember that I said the power rule works with just regular polynomials. And this is a polynomial divided by a monomial really, but this doesn't work. But it doesn't mean that you can't do it. It just means that we're going to fix it. So we're going to take this and we're just going to turn it into something that we can find the derivative of. And we're going to do that by just dividing each of these terms by this 3x squared in the denominator and just rewriting it as a polynomial, okay? So we're going to do the negative 4 over the 3. So we're going to write that as negative 4 thirds, and then x to the 6th divided by x squared, you'd subtract, and that would be x to the 4th. And then plus, and then write that as 4 thirds. And then x to the 5th divided by x squared would be x cubed. And then 3 over 3 is just 1. So x cubed divided by x squared, that's just a minus x. So we've now gone from something that we cannot use the power rule on to something that we can use the power rule on. And then we're going to do exactly what I just taught you there. So to find the derivative, we take this exponent and multiply it by that coefficient. And so that would be negative 16 thirds, and then that decreases by 1. Bring this and multiply it by that coefficient, which would just be a 4, and then decreases by 1. And then this guy, don't let that confuse you. That's really x to the 1st, and there's really a 1 in the front. So when you bring that down, that would be minus 1, technically x to the 0, but remember x to the 0 is just 1, so I'm not going to write it. My guess is Newton might accept it, but we should all know that x to the 0 power is just 1. So I'm going to leave it just like that. I think that's the safest bet. Okay, I want to show you something super awesome. So in the last video, we did this problem that took forever. Do you remember this guy? We had to do continuous and set them equal and find the slope and do all this crazy work and find the slope. Well, I want you to look at this. If I had known the power rule, I could go from here right to here. Okay, look at this. I would take that 2 and multiply it here. So 2 times negative 2 is negative 4, x to the 1st. Look at that, negative 4x. Look right there, negative 4x. And then this one is technically x to the 1st. So you'd bring that down. Well, 1 times a is just a. And then again, x to the 0 is just 1, so we don't write that, right? And so that would just be a, and then you'll learn in just a second that the derivative of any number, any constant, is 0. So that just goes away. So just by what we're learning right now, we could have gone right from here to here and skipped all this work. Not necessary, because power rule gives you that right there. So that is kind of awesome. So just in this short time, you've learned something that would have saved like a lot of time there, right? Okay, and then what I was just talking about. Okay, if they give me just a number, which is called a constant, right? And we want to find the derivative or the slope. Okay, I want you to think about what this looks like. If I was going to graph that, that's y equals 8. So that would be a line up here at 8, just going like horizontally, right? Well, what is the slope of any horizontal line? And the answer is 0. The slope of every horizontal line is just 0. The constant rule says that the slope of a number is 0, right? And sometimes they're going to try to trick you and make it look like it's not a constant, but look, do you see any variables in here? Number, 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 and pi is a number. Number, 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 constant. And so even if it looks crazy and they're trying to trick you, that is a constant, so the slope is 0. So that is super awesome. And again, that works on anything that's just a number. The slope is just 0, so when you're finding the derivative, it just kind of goes away, okay? So then there's only 2 more. This lesson is a little bit easier just because we know the shortcuts. So the next 2 are all about writing equations of lines. So I want to remind you of this little algebra 1 equation that we learned, which is y minus y1 equals m times x minus x1. So that is called point slope form. And it says that you put your slope right there. And then your point goes here into the x1 and the y1. This variable x stays and this variable y stays. So your point goes here, x and y, and your slope goes here. So there's going to be 2 separate questions that come up first. Sometimes it asks just for slope, and sometimes it asks just for the equation. So I'm going to stop when I get to the slope and make sure that you see that. And then I'm going to keep going and find the equation so that we know how to do both. Okay, so first of all, I don't have to do the equation thing like I did last time. I now know the power rule. So I can find that equation for slope in like seconds, right? I'm just going to use the power rule. So I'm going to bring this 2 down front. So that would be negative 2x, and it decreases by 1. So that would be x to the first. And then this is really x to the first. So I'm going to bring that down front. So that's negative 3. That would now be x to the 0, which again, I just don't write. And then this is a constant number. So the derivative is 0. I'm not going to write minus 0. That would be weird. So the derivative of this is just that, power rule. The derivative of this is this, just this. So if it says what's the slope at x equals negative 3, all I have to do is take that and plug in negative 3, which would be negative 2 times negative 3 minus 3, which would be 6 minus 3, or 3. So if I was doing a question and it just said, what is the slope? I would say 3. The slope at negative 3 is 3. Okay, that's the slope. But sometimes it says, what's the equation, right? So then I have to do this. So I have my x and I have my slope, but I don't yet have my y. And so what I'm going to have to do first is just figure out that ordered pair. So using this equation right here, I need to find like the actual point, and they gave me the x value. So all I need to do is plug that in. So if I plug in a negative 3 right here squared, that would be 9. So that would be negative 9. Negative 3 times negative 3 is positive 9. So those cancel. So that would just be negative 4. So I would get the point negative 3, negative 4. Okay, and then I have everything I need to use this formula right up here. And so I'm just going to plug it in. I'm going to do y minus y1, which would be negative 4. That's going to turn into a plus, equals m times x minus x1. And then that's really y plus 4 equals 3 times x plus 3. And then they always want it in slope-intercept form, y equals mx plus b. So we're just going to do a little bit of a switching around here. I'm going to distribute that in. So that would be 3x plus 9. And then I'm going to subtract that 4. So if it asked for the equation, I would say y equals 3x, subtract that over, plus 5. So you've got to read, please, please, please read what it's asking for. And if it's asking for the slope, stop here. And if it's asking for the equation, go all the way to here and make sure that you give them that equation. Okay? Okay, so then we get to the very last thing, which is like, oh, so close to the same except a word change. Notice that this is talking about the tangent line. So in the tangent line, like the slope is just the slope, there's no tricks. Okay, but then they ask almost the same thing, that they want the equation of a line that's normal. Okay, well, for your purposes, just understand normal is like perpendicular. It means it's hitting at a 90-degree angle. So remember from past math classes that when you've got a perpendicular line, the slope is the negative reciprocal. So it changes signs and it flips over. Okay, opposite reciprocal, negative reciprocal. However you want to remember that. Normal is like perpendicular, so you have to change the sign and flip it over. Okay, so we're going to do almost the same thing we did here. Only we're going to have to change the slope, because instead of being the slope of the tangent line, it's the normal line, which is like a perpendicular line. So I'm going to follow the same steps I just did. So first, I'm going to find the derivative, because I still need a slope. I can't have an equation without a slope. And I'm going to use the power rule. So I'm going to bring that down front. So that would be 3x, and then it decreases by 1. I'm going to bring that 1 down front, minus 4, but then that's really an x to the 0, so I don't write that. And then the derivative of negative 2 is 0, so I just don't write that. So this becomes this when you use the power rule. Okay, and then I'm finding that at x equals negative 1. So now I'm going to plug that in and find the derivative at negative 1. So that would be negative 3 times negative 1 squared minus 4. That's just 1. And negative 3 minus 4 would be negative 7. Okay, but hold the phone. I want the slope of the normal line. So if the slope of the tangent line is negative 7, then the slope of my line is the opposite reciprocal. So it goes from negative to positive and reciprocal. So that's the slope of my line. Okay, so slope of the normal line. Okay, but I'm not done. It said find the equation of the line. So now I've got to go through the same thing I did before. I need a point. So they gave me negative 1. Please plug that into here. You're finding the point here. Please plug that in here. So if I put a negative 1 in here, negative 1 cubed is negative 1. Negative 1 is 1. This is 1. Minus 4 times negative 1, that turns into plus 4. So I have 1 plus 4 is 5. Minus 2 is 3. Okay, do I have a point? Yes, check. Do I have a slope? Yes, check. So use this point slope form. Okay, and just plug it in. So that's going to be y minus y1 equals m times x minus x1. So minus a negative 1 would be plus 1. Okay, and then again, Newton always wants that in slope intercept form. So now you've got to just distribute and plug it or change it around a little bit. So y minus 3 equals, distribute that over, 1/7 x plus 1/7. And then I'd have to add that over. So my final equation would be y equals 1/7 x. When I add 3, it's 3 1/7. But as far as I know, Newton doesn't have a place to put in mixed numbers. So 3 1/7 is the same as 22/7. So for ease of entering it into Newton, I highly suggest you go to improper fractions. Okay, and that's what it's asking for. It's asking for the equation of that normal line. And so this would be the answer on this problem that it would want. The equation of the normal line. Remember, a normal line is like a perpendicular line to the tangent. Okay, and that's it. The second homework assignment took me far less time than the first, so I hope that you find the same thing, and good luck.